welcome to Pomodoro Joe for Friday, November 3rd, 2023. Today we're looking at LeetCode problem 1441. Build an array with stack operations. This is a medium problem. Whoa, look at this description. Wow. So we're given an array target and an integer n. You have an empty stack and two following stack operations. We have a push, which will push an integer to the top of the stack, and pop, which removes an integer off the top of the stack. So that's your standard stack operation. You also have a stream of integers in the range from 1 to n inclusive. So that just means we have an array of numbers ranging from 1 to n, and they're ordered in that order. Use the two stack operations to make the number in the stack from the bottom to the top equal to your target. So we're given this target. Oh, C++, I don't think so. All right, so we're given this target and an n. So we're trying to match our stack to this target. But the only thing we're allowed to do with our stack is we can push elements from our stream to the top of the stack or pop elements off the top of the stack. All right, if at any moment the elements on the stack from the bottom to the top are equal to target, stop. Okay. All right, and then we need to return the stack operations needed to build the target. So we return strings, push, push, pop, push. Okay, so here's our example. Our target is the array 1, 3. So it's a 2-element array with 1 and 3. And our stream is from 1 to 3 inclusive. So our stream is going to be 1, 2, and 3. So we'll look at the top of the stream, or the first element in the stream, so that's 1. We'll push that onto our stack, so that's a push. All right. Then we'll look at the next element on our stream. That's going to be a 2. Let me diagram it out over here. So here's our target, 1 and 3. And then here's our stream. We've got 1, 2, and 3. So initially, we'll grab this 1, we'll push it into our stack, and we're good. So we'll move on to the next thing. So that takes this out of the stream. Next, we have the next part of our stream. It's a 2. Well, we're not allowed to just skip numbers. So we actually have to push this 2 onto the stack. Actually, let me show our stack here. So we added 1 to our stack. So we pushed 1 onto the stack, now we get this 2. Well, we actually have to push it onto the stack. So we'll do a push, that removes it out of the stream. But then we don't want this 2 on our stack because it's not in our target. So we have to do a pop to pop it out. And then we'll do another push. So we'll push our 3, and then our stream is empty, and we have our target. So that's going to be a push, push, pop, and a push. Cool. All right. So let's put 25 minutes on the Pomodoro timer and we will get started. Okay, so we'll start with some result. It'll be an empty array to start with. And then we will return our result at the end. Now I think it's super tempting to actually perform these operations, build these stacks. You take the stack, you pop things out of your stream, push them in the stack, and then pop them out of the stack, things like that. I don't think we need to do that though. If you notice, these are all increasing. Our stream actually goes from 1 to n, and it increases as we go. So what we really need to do is just look at our number and find out, well, what's the next number we're expecting to get? So if anything is below the number that we're looking for, we're going to have to push that number, like this 2. So let's see, we're looking for a 3. We only had a 2. We had to push that 2 onto our stack and then pop it out. So basically we have a target we're trying to get to. And our stream is always increasing. So as long as our stream has values, or the values that we're popping out of our stream are below our target value, we're going to have to push and then pop, and then do another push and another pop. So for us, I think we'll just go through and calculate which pushes and pops we need. We don't actually have to build these stacks. Okay, so with that, we'll get started. Let's see, we'll have some stream. And now our stream will just be the range from 1 to n inclusive. So we have to do n plus 1 because this range is exclusive. It doesn't include this last value. And let's see, let's keep track of where we're at in the stream. Let's call this stream index. So this is where we are in our stream. All right, and then we also might want our target index. But instead of actually having a target index, I'm just going to assume that every value in our target is going to be our next target value. So for our target value in our target, so we're going to go through every value in our target, and we're going to look for that value in our stream. Okay, so let's see, what's the best thing to do? I guess we're going to look at our stream value. So if our stream at this stream index, if that is less than our target value, well, at that point, we're going to have to push this value onto our stack and then pop it out because we need to get to the next value in our stream. So we could do a push pop here. So let's do that. So let's do result. We'll append. Let's see. We'll append a push. So we'll push this lower value onto our stack, but then we need to pop it out because it's too low. So then we'll do a pop. Now our index will increase, so index or stream index plus equals 1, and then we'll continue. So we're going to keep going, but this isn't quite right. When we continue, we're going to be going on to our next target. So we don't really want to continue just yet. We want to say, while this stream value is below our target value, then we're going to keep going until we find our value in our stream. All right. And now that we found our value in the stream, let's see, we can do if stream at this stream index, if that's equal to our target, well, now we found the target we're looking for. We're just going to push this into our stack, but not pop it back out. All right. And then we do need to increment our index, our stream index. Okay, so we're going to go through every target value in our target. While our stream is too low for our target value, we're just going to keep going through. We're going to do a push and a pop, push and a pop, moving through our stream. Now at some point it's going to equal our target value. So we might not even need this check here. We might just assume that it's equal to our target value. But at that point, we're going to push our target value from our stream into our own stack, which we're not actually keeping track of here. We just know we're going to do it. Cool. I think this is actually it. So we're going to go through while our target value is greater than our current stream value. We're just going to do push pops. Then as soon as we get our target value from our stream, we're just going to do our push. And at the very end, we'll return our result. Let's see if this works. I missed an R. I'm not going to do that. Let me just fix this typo. And now we'll try this. See if this works. And it works. Let's submit this and see if we can pass all the tests. And we pass. Let's see, we actually do pretty well. We beat 86% for runtime and 44% for memory. So yeah, that's pretty good. Now one thing we could do, I'm just curious, we can jump back here. We're always doing this push and pop together. What if we just did an append push pop? So we can do this. We'll append push. Actually, we'll not append, we'll extend. So our result plus equals another array here of push and pop. I wonder if this will help. This might make it a little bit faster. I'm hoping, but we'll find out. No, that actually makes it significantly slower. I'm really surprised by that. Now we're at an 18% for runtime and 44% for memory. Wow, that's shocking. I wonder, okay, I'm gonna try one more thing. I'm curious about this. I'm gonna create a variable out here called push pop. I'm gonna set it equal to this. And then we'll just do this. See if that makes any difference. No, wow. So our first solution was by far the best at an 86% for runtime and a 44% for memory. So we're gonna stick with this one. All right, well this shows you that you don't actually have to follow all the instructions, like you don't have to implement the solution the way they describe it in the problem statement. So instead of actually building a stack and doing all the pushing and popping, we're just going through and figuring out which instructions we would need to push and pop all the right values into our stack. Okay, I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.